All right, so we are starting with part two here of our uh, machining fundamentals lecture on materials. So we last ended with a few of the ways that you would see the shapes and forms of metal. So now we're going to kind of continue and delve a little deeper into that. So the most common way and the least expensive material, of course, is bar stock, or what they refer to as billets, and of course sheet goods like rolled sheet metal. Um, Now, when we talk about bar stock, that could be round bar stock, it could be square or rectangular. You might have uh, it in octagon or hexagon, so you can buy metal in a variety of different types of general shapes, depending on what your actual machining needs are. So it makes it very nice and convenient. And of course, generally, that is done by your fractional sizes on the imperial system. So, or you may also be able to buy it in basic metric sizes there as well. Although here in the States, most of the time it's imperial fractional sizes. Sometimes there's some allowance and clearance depending on whether it's hot rolled steel or cold rolled steel. Uh, but for the most part, it's going to be pretty close to the actual size, um, fractional sizes, an inch based measuring system. Then we get into castings. Now, you can have all sorts of different types of castings depending on the metal that you're using. So, it is castings are generally not quite as strong, especially if we're talking about cast iron. You can get cast aluminum, cast brasses, and bronzes are all providing cast. They are very accurate. So again, you do need to have a mold. So somebody has basically either paid for a very expensive mold and core box, or it might actually be done by a lost sand casting method and using other types of casting methods as well. So I think if you were part of the manufacturing processes class in the past, you've kind of seen a little bit of a sand casting method when we did the aluminum melt, or and that would be very, very similar to this. So you also get a good detail on internal features of this as well. So castings, if you have a lot of internal features on a part that need to be made, a casting is one of the ways to go. Although you may or may not be able to get inside of the casting to actually machine and remove any material from there. So the design engineers and engineers in general usually take a look at their designs and make a decision on what the best way to provide the raw form of that material is. Forgings are a very strong part, so and you will get different types of forgings. Of course, if you think about this, some of you probably watched Forged in Fire. This, of course, is larger parts that are also forged. It's kind of similar. It is a throwback to the old days where we would use a hammer and anvil and strike and shape metal. But in this case, we are taking the metal and it is being forged or in a big stamping press. It's coming down into these dies, and it's basically either cold or hot formed in these stamping presses and die presses to actually shape that out. Now, a forging part does give a very strong part. So we're not really going to go too much more into some of the differences here between forged parts and cast parts and raw billet good or bar stock. That, of course, is in the industrial materials class where we'll go a little deeper into that. Extrusions are another way to get different types of shapes. So if you can think about probably one of the most common extrusions out there would be your angle irons. So if you also think about U-channels or some of your structural steel with your I-beams and H-beams, those are all different types of extrusions that would come in that you might need to do some work on those as well. An extrusion basically has a die created as well, and the metal and the material is more or less pushed through that die. So it's another way to give a fairly strong part along the axis, but there are some other limitations to that as well. And there are still times that you will need to machine these parts and this material too. All right, so now that we've kind of got that, those different shapes out of the way, we will talk about the 5 basic metals that you need to go in. Now, this particular textbook is predominant on the metals side, but be aware as a machinist that you will have, besides machining metals, there are times where you'll be machining plastics and other different types and grades of material as well. So it's not always just machining a metal, but we're concentrating with that mostly in this particular class. So the 5 classifications here that they are giving you is aluminum, cast iron, steel, stainless steel, and brass. So, and brass, of course, is a member of the copper family. So brasses and bronzes. So we'll kind of talk about these 5 different materials in this. So one of the ways that the textbook kind of goes through to refer to this, and you will get used to kind of taking a look at it, but they talk about this mnemonic here of C, W, M, S, F, and U. So where you have color and hue, so weight, so a magnetic attraction, a spark pattern, and a spark color when it's ground, a filing method to kind of test for hardness, and then any other unusual characteristics. Now, these are just some generalities. So, but if you do kind of remember some of this, you can help yourself to be able to kind of roughly identify some of the different materials if they aren't marked. So aluminum is, of course, has like a whitish type silver color to it. It's the lightest of the 5 metals. There is no magnetic attraction here. It also doesn't spark when it's ground. I personally don't like to grind aluminum. It's not really one of the things that I don't really consider grinding aluminum as a viable alternative. I'm going to, mainly because a lot of times your aluminum will pack up your grinding wheels and your, so a lot of times if you need to grind aluminum, you do need to make sure that you have the right type of grinding wheel to be able to do that. So, because you can pack up a general purpose grinding wheel and that can cause other problems as well. So aluminum file is pretty easy. So and it is one of the materials that is very, very easy to cut. Cast iron. So cast iron is also fairly easy to cut. So it's a dull black gray, not shiny. You can usually tell cast iron just because you can see the grain structure and kind of tell by the coloration it is fairly heavy. So the magnet is definitely going to hold. So if you do a spark test on it, you will see dull reddish sparks and usually coming out in blobs. It's very, very easy to file, but it's going to file like a powder, and you're going to know right away if it's cast iron because it's going to get, your hands are going to be black and gray and covered in that cast iron dust pretty quick. So it is definitely very, very dirty, and that's usually due to the large amount of carbon that is in cast iron. Steel is a bright bluish silver gray color, so you might have some dark carbon crust if it's hot rolled. So if it's cold rolled, you generally get a finer finish on the outside. So it's generally fairly heavy as well. So it definitely adheres to magnets. So you can see differences in the spark test, and you can go in their charts that kind of give you spark patterns and kind of color codes for the sparks to kind of identify that. Steel's pretty easy to file, so you do want to make sure that you have the right types of files to use when you're filing that. Of course, if the steel has already been hardened, then that's one of the indications it's going to be a lot harder, and you're not going to be able to use a file on it because of the hardness of it. And so that's steel. So as we talk about stainless steel, so you can kind of see the list here. So um, stainless steel is kind of notorious for when I've machined it, it tends to leave a lot of burrs. So um, and it burrs up a lot more so than regular steel. Uh, so you'll notice that when you're cutting it. It's kind of it does have a much higher silvery type color to it. Although after machining, depending on it's sometimes difficult to tell the difference in color between tool steels, some of your tool steels and your stainless steels um, as well. So color isn't always a viable choice there. Weight of stainless steel isn't that much different from regular steel, so that would be kind of hard to determine that. So uh, the big way here to kind of distinguish between stainless steel versus or regular steel would be in the terms of the magnetism there. So and your spark. So this is one of the reasons why they're kind of going through this. These are kind of some simple things that you could do if you aren't really 100% sure of the material. So this gives you an idea of some of the things that you could do to kind of try to identify that. But and of course, we all know that stainless steel does not rust. So that's one of the reasons why it is used heavily in the food industry. A lot of your cabinets and kitchen grade material and food related products need to be stainless steel because it doesn't uh, rust. And of course, rust in our food sources wouldn't necessarily be something that we would want to be ingesting on a regular basis. So brasses, I think you can all kind of generally distinguish between your brasses, between brass, bronze, and coppers. Um, so your copper, of course, is pretty common to see, and I think if you were to have a piece of copper with brass and bronze, all three of those lined up, you would probably be able to kind of tell the difference between it just because of the coloration there as well. Uh, Brasses and bronzes can also be kind of heavy and fairly dense. So again, your magnets are not going to stick to it. Generally, it's not going to spark either. Brasses and bronzes, they file pretty easily as well. So and again, there are also a lot of different properties here with this particular type of material too. So as we kind of go through some of the rest of this, chapter 5 is pretty long, so it is not the most exciting of the machining related topics and subjects. However, as a skilled tradesperson, it is pretty important for you to know and understand a lot of these differences. So there's a ton of information there that you need to know. And of course, in my 30 years experience, um, the different types of materials, there have been changes. So the longer you are in machining, especially if you're in a job shop environment, you are going to be exposed to a lot of different types of um, materials. So and get more exposure to machining those. Of course, if you are more of production machining and for a large company, you're going to basically be machining the same type of material over and over again, and then that gives you the benefit to really, really get to know and understand all of the cutting processes and the best way to actually work that material too. So be aware of this. I know this isn't exactly the most exciting of subjects, and we all want to go right to the machine and start to crank dials and cut and see the end result of our parts. But there is a lot of other information that we need to know and learn so that we can be able to problem solve when we do get problems that creep up onto the factory floor, or when we're trying to cut something and we're breaking tools